But before I start, Ray, I want to answer your question from last year. If you remember, and it's been nagging me for a year, believe it or not, last year, one of the things that we showed a single client performance, we showed the system performance, we showed that while dropping one storage node, the system initiated a rebuild, and there was no loss of performance, if you remember that. We also showed cloud tiering. We're going to see a lot more of that this year as well. But I was showing it with the writes throughput, and your comment was writes are easier, show it with reads. So that's kind of like an overview for everybody. If you never saw the system, this is the UI interface. Everything that I'm doing here and showing here can also be done using a CLI, and we actually have customers.
Scripted.
Sorry?
And scripted.
Yeah, I was about to use the word automated. And we do have customers automating our provisioning, creation, expansion, and we'll see a lot of it. So this is a live system that we have in our lab. As you can see, these are the storage nodes, representation of the storage nodes, drives, CPUs. And we're going to see how it works. And what I want to do first, I want to show that dropping a node while loading the system with IOs doesn't decrease performance. And as mentioned last year, I want to do it with read IOPS. So you're not so first of all, let's see that Weka file system is mounted here. OK, it isn't. We see that we have two file systems. By the way, you can already see that one of them is encrypted, one of them is encrypted, and we'll show how we're configuring the encryption. OK, so we want to do, we just want to mount the file system, and this is how you mount the file system. I'll just go to a server that is acting as a client to our storage environment, because as Liran mentioned, the storage environment can be running on the servers that are converged with your applications. So running the storage environments alongside your application. We segregate ourselves in a container where we're not affecting the applications. So essentially, when you install us, you can decide how many cores and how many network and CPU and RAM we're taking, and all the rest is taken by the application. And we do have customers. Actually, we have a lot of customers running GPU environments where they bought GPU servers and they want to fully utilize them. And another option would be to... Yeah.
Could you use the whiteboard just to draw up what this looks like logically, the way you've sort of got this configured? You know, because you just said that you're running the client on the server. So if you've got other servers that are running the storage, just a really, really quick diagram might be useful just to see.
Definitely. So imagine that in this environment, we have 8 servers. It's actually 2 super micro big twins. Each of them has 4 nodes. Okay? Each of them has 6 NVMEs. So it's a total of 24 NVMEs per server, per 2U. So it's a total of 48 NVMEs in the environment. And then there's an additional big twin where one server, I call that Weka 9. You'll see that as the client. That's only connected in 100 gig E.
So you're running all the demo stuff off Weka 9, talking to those other servers.
Exactly, exactly. And that could have been, that's Ethernet, could have been InfiniBand, could have been either. So, so as you can see, I have Weka mounted, and this is the client experience. The client just sees a mount point, doesn't see an object store or anything, doesn't see a block device, doesn't need to format it with any local file system, and we'll talk about the performance that Liran mentioned and I committed to showing. Okay, let's just do a simple 1 meg read.
Your kernel module, is it a kernel module that's installed on Weka 9 to
So there's our container. our client agent. It has a very thin VFS kernel module, but basically it throws everything to our user space agent.
Okay, so it's just like a shim layer to get you back up into user space.
It's just, exactly. So let's just start running IOs. Okay, so in the recorded version, it already had the laid out files that the FIO will now create. But what we want to do essentially now, we just want to load the system and then drop a node and see what happens. And again, this is random reads. I hope that will satisfy your curiosity. I'm sure you also thought about it for the last year. Couldn't sleep at night. Does Weka really do what they say they do, or they just showed something? While that's ongoing, if we'll go just to the UI, so this is kind of like how the UI look and feel like. And what we saw in the last few years, there's the stickiness factor. A lot of customers that are using a high-end distributed file system are frankly annoyed, because if you ever manage a Lustre or I won't mention other names, but it's not a fun, trivial thing. We kind of like give the NAS usability, the ease of use. What you see is what you get. There's not a lot of tweakables. You don't need to tweak the system for IOPS or for throughput. And actually, we'll see that the same file system can perform both in a way that other file system cannot. And I think due to the Wi-Fi of the hotel, it connects, it updates slowly. But basically what we see is that it's the main dashboard. There is a very extensive event log showing the system, what the system did, very extensive statistics, so we can basically go, and while we're waiting for the FIO to kick in, we can actually go and look at the statistics. So basically every POSIX op that you can do can be queried. So you can have a very easy view of what the system is doing at the moment, not just reads and writes, but a lot of metadata as well. And you can also drop down to the granularity of who's doing it. So if you have a noisy client, a noisy server, a server that is flaking with the network, it's very easy to see it here. Okay? System is still creating the data set.
So have you had customers look at that and think that that would be a way to work out how to optimize their application?
It's interesting. We have a lot of customers where we go into an engagement, and the customer thinks that his application works in a certain way. And when we go in, we look at the statistics, and then it's like, oh, no, it's actually, you're doing 8K instead of 16K. You're doing 4K reads or writes.
Yeah.
Definitely. Or the metadata. Another thing that we're doing is we have our own client, right? And unlike NFS, NFS is very chatty, very metadata chatty. We're not. So we're dropping all of that and allowing them to push their data instead of just doing a lot of metadata. So while that is running, maybe I'll jump.
You can show them the file system, the object.
Maybe I'll just show the how do we configure. Liran mentioned encryption, that we can create encrypted file systems. So while that data set is being created, let's just go over that. So creating a file system, it's as easy as going and add a file system. Oh, I don't have capacity. What will I do? Let's just steal it from another file system. So let's just decrease. This is the file system, by the way, that we're working on right now, doing IOs. There's no need to pause. Let's just decrease it to 10 terabytes. OK, while everything is still running. And by the way, I think I mentioned it last year as well. This usually, it's such a tiny feature for us, but it gets us the wow factor every time. You can have thousands of clients connected to the system, running IOs, mounted, and you change the file system size under the hood while they're still running. That's huge to many customers. So add a file system. Let's call it whatever, file system 3. Do I want this file system to be expanded over to an object store? I don't have to. Let's say that we don't. Do I want this file system encrypted? Yes or no? That's a nice option, because And it's as easy as that. Let's create an encrypted file system. That's it. At this point, we have a file system. You can see it's encrypted, or you can see that we marked it as encrypted. We actually connected this system to a HashiCorp Vault KMS. And it's a pretty simple procedure. I'll provide actually the videos afterwards. It's basically just provide 4 parameters here. These 4 parameters. What's my KMS? What's my URL? The key and the token, boom. And that's it. At that point, what happens is that the system is now not saving the keys, the customer keys. We don't want to own the customer keys. We don't want to now start certifying our system for every customer security requirements. So we're actually leveraging the KMS. Customers that are sensitive to it would like to use their own anyway. Okay? So at this point, we created an encrypted file system without requiring to connect to any Kerberos or trying to. I see you smiling. Is that a question or something?
No, I'm good.
Awesome. So, any questions on? Great. So while we're doing this, the system kicked in. This is a single client. Single client connected to the system is doing 11.3 gigabyte per second, which is basically almost saturating the 100 gig link that it's connected through. I showed this last year, and I actually plan to show also a demo this year where we're doing a client connected over HDR doing 23 gigabyte per second. That's nice, but now Liran topped it with 73. So what can I do? A big thing here is, and actually now let's do what we wanted and just drop a server. Fair enough. Okay. Let's just go to one of the storage nodes and drop it. The internet is weak today. So again, nothing fancy. IPMI tool, power cycle, just like dropping the power while the system is running. And while we're doing that, let's take your advice and.
This is from Weka 1. Is this what you wanted?
Mm-hmm.
All right.
Because the other one is doing the other thing. Oh, but actually, I want to show this first. So while the system is dropping, we drop the storage node, right? You'll see that the system is reporting that it's rebuilding. And performance, you'll see for a few seconds that it takes us a few seconds to actually identify that the storage node failed. And then performance goes back to what it was before. Does that answer your question from last year?
Yeah. What do you expect me to say?
Yes, Shimon, now I can sleep at night.
Yes.
Awesome.
I need to think of a better question for this year then.
I'm going to show plenty, so you'll have a lot. So
You want to have him awake at night for 2 years or something?
no, it's funny because I was thinking about showing this for the last year, and I just talked about it this morning with Liran, and Liran also remembered it, so apparently it's bugged both of us. So that's one thing.
Holding it against you, right?
Sorry?
I'm sorry. Let's go.
So now let's try to work with the encrypted file system. I'm running on that because it's less relevant. We'll just create it in the background. But actually, before we do that, one of the main things that I wanted to show here is that we're saying performance, 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 and we're always talking about throughput. But as Liran mentioned, performance is not only just throughput. Performance is also latency, and performance is IOPS. Okay? And one of our big claims is that we can do also IOPS as easily as we'll do the throughput.
So the software is licensed for on capacity, right?
On capacity, on usable capacity.
On usable capacity. So do I have any benefit if I use very small nodes instead of large nodes, for example? So can I have some advantages in using few devices for each single?
So it's a great question. The system can start at any point and expand and shrink on the fly, and we'll actually see that. We have seen customers that started with, it was easier for them to buy servers and not fully populate them because they could budget it on day one. And on day two, they can just put in NVMEs, and that's an easy purchase for them. That's one advantage. Technically,
I don't know if it's a corner use case, it makes sense, but if I buy servers with 4 SSDs, for example, and I want many of them instead putting 20 SSDs in each single server. Does it make any sense?
So
parallelization
if you look at these servers, we like the big twin or the big twin-like solutions because we're actually quite good at getting performance out of the SSDs. And for a 100 gig link, you need between 4 and 6 SSDs. So you don't get more performance if you put these 2U24 ones. So if you want to shoot for the highest performance, you should think about keeping this ratio of 4 to 6 SSDs per 100 gig link.
And because the efficiency on the way you manage the file system, I don't need a lot of CPU, I guess. So small nodes at the end of the day.
Right, and then we
parallelize across all of them.
These 1U10 drives we put many times now with InfiniBand HDR, which is 200 gig InfiniBand, or 2 cards with 100 gig Ethernet. So if you buy the 1U10 drives, you will just put 2 NICs, and then you get good ratio. We usually don't recommend going with the 2U24 because there are no real solution with the 4 NICs and then you're not going to get all the performance you get out of these devices. And nowadays you can buy big devices, so you can buy already the 15T and soon you'll be able to buy the 32Ts. So you basically have to decide what kind of capacity do you want.
And can I have multiple Ethernet interfaces in the same node? So maybe 4, 100.
And we leverage them in a HA way. So you could say, hey, I'm connecting that node with 200 gig links and to 2 different switches. Because we want it to be completely redundant. We said sun-like resiliency. So we really are sun-like resiliency, unlike what you usually get from the filers. And as long as you have the 2 networks up, you're going to get the aggregate of the 200 gig. But if now one link failed, or even if one complete network failed, like one fabric failed, you drop down to just 100 gig.
Shimon, can you show us the response time for this workload?
Sure.
With the GUI?
Definitely.
And it would be like overall response time? Is that how I would classify this?
So that's the latency as the system perceives it, and there's the latency that the application will perceive. Okay, in this case, we're seeing usually that what you'll see here is double digit to.
And it's metadata I/O as well as.
It's a file I/O, exactly. It's the open, close metadata and read writes.
And these are latencies you get from battery protected RAM-based SAN. And once you layer a file system over it, you have to run 2-3 IOs to get an IO. We're actually showing an end user usable I/O.
The latency is varying between 100 microseconds to almost a millisecond here.
So the millisecond is if you do an open or a close or a move. So it's not just the I/O. If you go back to the FIO results, you're going to get the averages from the FIO, and FIO will only count the actual I/O. And if you compare how fast we run metadata operation, it's still going to be an order of magnitude faster than the filers or local file system.
Is there any ability for like QoS or just to kind of have like more consistency in the performance?
So to do what?
Like throttle? Can you throttle like file systems or?
So all of the file system is distributed across all of the environment, and they're actually sharing the same fabrics.
These are NVMe SSDs in this configuration?
Yes.
And you're using the NVMe over Fabric client capabilities? Are you getting these response times?
We are getting this response time because A, we have very effective and efficient networking stack with kinds of the NVMe over fabrics, but because we are managing the queue depth over all the devices. So it doesn't matter what IO you run, you get the best latency. So some of these IOs, instead of reading from the device that may have a higher queue depth, will read from the 4 others and reconstruct it because it's faster for you, and it keeps our averages lower. And this is where most of the smarts are, because we're the only storage that we give you promises on response time, and that's what applications really care about. And we have more smarts. So you have tons of companies saying, hey, we're leveraging over fabrics and we're doing RDMA, but when they are bottlenecked, you see that latency increases. For us, the latency does not.
What other, so in the 4+2 configuration, right, you've got 2 parity and 4 data. So there are no other devices where the data actually exists, right? So if I'm going to do a read for a file element, but the data is going to be on one of those devices and a parity.
Right, but if the queue depth for that device is higher and we would think, hey, it's going to take a millisecond to get that result, we're going to perform 4 reads from other devices and reconstruct it quicker.
You can do 4 reads from other devices with parity and reconstruct the data that's sitting on the device that's got a queue depth that's...
So you can get your data quicker.
Jesus Christ.
But response time matters. This is how we show customers that they switch to Weka.
You're rebuilding the
and they
data
run
in flight so as to guarantee a response time.
So your CPU
across
never waits
4
for
different
data.
devices you're reading.
Because reads are, if the queue depth is low, it's free. If moving over the network is there. And what CPUs care about is no IO wait times. And this is what really makes a difference for the applications. This is how customers switch to us from an extremely expensive all-flash array with a local file system on, and they get 3x, 5x faster application runtimes.
So what are the applications? Like, can we talk about that for a minute?
Can I show another thing, and then?
I'll actually address that in my section as well.
We keep talking about that, and now I have a question. Do the applications, do they have to be new applications? So if we're really talking about faster than anything, if it's brand new applications that are being written to a new protocol.
It actually does not require rewriting your application. Actually, we're just seeing an acceleration of performance just by taking current applications and moving them. I'll give some example, some genomics workflows that are currently running with NAS appliances or with local storages. Just by running them on Weka, you benefit. Liran mentioned some of the reasons. Just by having us provide lower latency, immediately improve some of the CPU-bounded applications, some time series databases. Okay, some time series databases that we've seen at some customers, and obviously machine learning and inferencing and training environments that we've seen.
All of that that's not, so what, that makes it sound like your market is not the enterprise. Your market is where they're building these very huge scale-out applications, because their application can be written to how you're building this to take advantage of new ways to provide the throughput. But that's not looking at an existing enterprise that has applications written for the normal standards.
So what we're doing with the enterprises, and we have quite a lot of financials, they have been doing a local file system optimizations virtually for the last decade, and that's the reason Fusion IO ended up being so successful. That's the reason customers buy, a complete all-flash array per each server. And we're going into these use cases and tell them, hey, you don't need to run a local file system over the fastest NVMe or a Fusion IO you can buy. You don't have to buy an all-flash array per client caching the local file system, because we're going to let you share your data. And then their problem is that they start by copying the data locally, doing the computations, and copying the results back, which also wastes time. And we just let them run directly off of their data pool. So they don't have these steps anymore. And there are many, many applications where today the best practices is to cache locally. And if you have to have it backed up and protected, the best case is match a beefed up client with its own all-flash array, just so you can provide the right level of low latency IOs.
Does that answer your question?
Sort of. Yeah. Go ahead.
Awesome. Because we are taking current environments, and just by placing Weka over there, we're...
And another thing we do, we let customers do it on the cloud. So we have a lot of the financial that now have a mandate to move to AWS, where they cannot use EBS or EFS to actually run their application for either scale or performance. And we let them run with Weka, and they actually have the ability to run their enterprise workloads on AWS.
Okay, we talked also about data mobility, about the ability for Weka to connect to an S3 bucket, to an object store on-prem, one or more. Actually, I wanted to show the ease of use of that, and basically how flexible it is. So basically, and that's a demo that I think that we can see, because it's mostly UI. This is my system. My system is connected to 3 different buckets. They could be on-prem, off-prem, or any mixture. And it's as easy as creating a file system and telling it to expand the namespace over to that object store. So in that essence, the customer is seeing a file system, as we mentioned, and it doesn't see the object store. It doesn't need to talk about with object store semantics. So definitely also taking today's application, not requiring to do any rewrite. And then we can expose the object store capacity, not just the flash tier capacity. We will, for those of you that are not familiar with it, we can move the data. We will move the data back and forth. Now, the agility here, and that's, I think, what we want to see in this demo, is the ability to have our file system connected. In this case, it's connected to OBS1. Again, could be an on-prem object store, could be a cloud object store. And now we allow the customer to connect our file system to multiple object stores. So maybe I want to make sure that I'm expanding my namespace to an on-prem for performance, but I'm also backing my same file system to the cloud. So in case of a catastrophe, in case of a disaster. Okay, so I can just connect my file system to multiple object stores. Now, let's say that one of my object stores, I don't want to have any vendor lock-in. So if one of my object store needs to be decommissioned for some reason, I can just go and detach from that object store. So Weka will just move the data that it required from that object store, make sure that it's available only on the remaining object store. And then we can also...
And by the way, everything while IOs are running. So everything was on the one object storage. You added another one for extra durability. You suddenly didn't like the first vendor. You disconnected from him. And no interruption for data whatsoever, for work whatsoever. It's all up.
And we do have actually customers that are tiering to an on-prem object store to expand the namespace. And the same file system that are being tiered to the local object store also being tiered to the cloud as a zero-cost DR solution. Because if something happens to the local environment, you just spin up Weka in the cloud, connect it to the cloud object store, and continue to work.
So are you saying that by disconnecting it, you're still actually talking to the object store, but you're just not getting the acceleration.
By disconnecting the system from the object store?
Yeah, so the customer now just talks directly to that. Is that what you were saying there?
So imagine the scenario, maybe I will whiteboard it for a second. Imagine a Weka system. Can you guys see it? Yep. Imagine a Weka system.
Can you use another color other than the green? It's really hard to.
I will be glad. Can we use purple? Because that's our new color.
Sure.
Sure. So, does that work for you? Yeah. Awesome. So, this is a Weka system. Could be on on-prem.
Yep. Whatever.
On-prem. Okay. It's an optional component to connect to an S3 bucket. This could be your Scality, ActiveScale, SwiftStack. As everyone mentioned, it's a very saturated market. There are a lot of options here. We can connect to all of them. And now what you get is you get a file system that can expand the namespace. Maybe I have 100 terabyte of flash, but 20 petabyte of an object store. So now we can create a file system which is 20 petabyte. The clients are always seeing the POSIX semantics. Weka will move the data back and forth. Okay?
Okay.
Now, what we added, the ability now, is to also have that file system, which is tiered here, to be tiered to another object store. Could be on-prem, but could be a cloud object store. If this is the cloud, maybe this is S3 on Amazon, on AWS. So now your file system is tiering.
Think about it when you're backing to tape, that you're backing to the other tape and shipping it to Iron Mountain.
Yeah, I've got all that, but it was the way you said the I/O is not interrupted when you detach the bucket. But surely that's where the information is.
The metadata and all of the new data are always on the flash tier. Let's say that we expanded to one of the object store, but we connected another one. We will replicate the data. If you want to disconnect from one of the object stores, the data that is still here will move to the flash tier and will move to the other remaining object store. Okay?
You can only detach once the other one is fully backing up all of your data. So you cannot detach if there's some information.
Whatever.
What you can also do, by the way, is you can detach completely and say, okay, I have 10 file systems. For one of them, which I tiered, I don't want to tier anymore because suddenly I understand that I want all of the flash performance for that. So I detach completely and go back to the flash.
So does that get pulled through the file system during that replication piece, or is it a direct between the two S3 buckets?
It's through the file system.
Okay, so you need to, because you've got petabytes versus terabytes of file system in the flash side of things, how do you control it not taking up the whole?
It won't actually go through the solid state, but it will go through our servers. We're not telling the S3 to go copy it from, let's say, the Scality. It doesn't go through
the file system, but it goes through
It goes through the file system logically. It does not get saved to solid state.
Right.
So we manage it. We don't have to actually write it to NVMe before we move it to the other S3.
That's not a little... Okay. So am I missing something? Is it written and you're copying it already? Or this is while the write is happening, it doesn't really write and you copy it?
So when new data is written, and Red King's question was a bit different, but when data is written, it's being written to the flash tier, and there are some policies that push it to one or more object stores as needed. What we also discussed right now is the ability, and always, by the way, the metadata is always on the flash tier as well. So whenever you're
it gets written to the flash.
Yes.
And then things
Exactly.
Okay.
Exactly.
Right.
What we just discussed is once we detach from an active object store that could have data on it, we will move the data if it's not already there. By the way, it could be that it's there and we can just remove it. But we will move the data. The data that will be moved by the file system, but will not take capacity on the SSDs. So in that case, you will not overuse your SSDs.
I think it's the confusion around the word file system, I assume, is an area used for
the processes that are managing.
Processes themselves.
The file system itself is composed out of multiple software nodes, and which maybe we will discuss. Okay, but again, the message here is that what we're doing here is we're allowing the customers the full flexibility of starting with a system that is connected to one or more or zero object stores, then connect different file systems to the multiple object stores and move between them as needed. And we see customers doing that mostly for backups and DRs. Okay, because now you don't need another third-party data mover. And actually, we went to some customers that were using third-party data movers and moving the same amount of data through Weka or through a third-party data mover.
So in that instance, would you suggest maybe spinning something up in a cloud to help move it rather than hairpinning it back onto premises to send on?
So it depends. If your Weka system or where your compute clients are and what their storage needs are. If it's an on-prem environment, we will tier it to the cloud for you. You don't need to spin anything in the cloud until you really need it. So on day one, you can have your compute and storage on-prem. The on-prem system would tier to the cloud. And then if there's a disaster, or if you want to just burst to the cloud, which is also doable, you can just spin up a Weka system in the cloud.
And is it better to have that closer to the source?
Closer to the source?
Yeah, well, if the information's in the
closer
S3.
to the bucket on S3?
Yeah, sorry.
So S3 could be on a single location, or it could be replicated between regions. So usually you would spin up the instances where that data is on S3 to save on cross-region payments, actually.
And the end-to-end encryption and all that stuff is all managed the same way, whether it's on object storage or not. It's going to be encrypted if it was encrypted.
It is encrypted. We didn't talk a lot about the encryption, but imagine that every file is encrypted with its own key, and every file system is actually encrypting every file, and every system is encrypting every file system. And then that key itself is provided by the KMS. And in that essence, we don't save the master key ourselves. This is what the KMS does. When we save the data on the wire or when it's saved on the SSDs, it's encrypted. When we snap to object, it's also encrypted. And again, we will not keep that master key. So
that's all done by HashiVault.
Exactly. In this example, a different user might have a different KMS. We don't want to own the data. We don't want to certify our system to be a KMS. That's for customers to do.
And a significant use case for us, especially in Europe, we let customers have admins that run provisioning commands, but their actual internal customer never gave them a key to access the data. So we run, and hopefully we'll be able to announce some of these soon, we won several occasions where we were single sourced just by not letting the admin, we're the only storage that if the user does not want the admin to have read or write or whatever access to the data, the admin does not have. So in many cases, the storage admin can provision a file system, but then the KMS is actually owned by the business unit that runs the data, and they feel completely protected.
Okay. I have a few more things to show. We talk about it a lot. The system elasticity and flexibility. So we constantly say that the system can be expanded and shrunk on the fly. And this is kind of like, I think, the first demo that we show it. And this is how simple and easy it is. While the system is performing IOs, while the clients are connected, while everything is mounted, you can actually expand the system. You can actually add more server or more drives. In this example, we're actually adding a server. When we expand a server, we expand with CPU cores, which can act as NVMe over Fabric cores or as metadata cores. So essentially, you don't need to, if you're familiar with other file systems, you don't need to try to calculate the metadata to data ratio. We expand on both on the fly while everything is running. And just it's as simple as a next in a UI, or you can automate it using our CLI. Kind of like just choosing the NICs, the CPUs, and the drives that the new storage node will take.
Sorry, was that bare metal you started on? Or
yeah, this is a bare metal environment. It's a really good point, because one of the main use cases for bare metal, environment, for on-prem environment, we see a lot of customers starting at a certain footprint and then increasing it. But for cloud environments, what we see is that our customers are starting at a certain point. They can expand, but then they can shrink in order to decrease cost. And this is like a huge in the cloud environment.
Or if they want to flip instance type.
If they want to flip instances type, that's actually they can expand with a different instance type and shrink the other ones, exactly.
Are you able to say, or are you prepared to say how much you have in the cloud and how much you have on-prem in terms of your customer split?
In terms of the number of customers,
just what it
was 22% last year on the cloud,
right.
And the remainder on premises. But we have a significant number of the on-premises clouds customers that are doing cloud bursting now, which we don't consider those cloud customers per se because they're on-prem. But that's one of the big trends we're seeing is them starting to now play with the cloud bursting capability.
Right.
Yeah, and probably at some point we'll start accounting them as hybrid. But currently, if you started on-prem, we count them as on-prem.
So you said that you could automate with the CLI. Can you also do that with REST APIs, or that's not accessible yet?
So we're doing it with CLI right now. REST API should be coming.
It's coming soon.
Okay.
Yeah.
Do you plan to add any analytics functionality? I mean, large file system, everybody's talking about adding analytics to see what is happening to the data that is stored in the file system. So not just performance, but actually actionable data.
So actually, great question. We've seen customers actually partnering with other solutions to do it. Can mention a few names. Starfish, for example. We have a customer that is using us in conjunction with them to do that analytics. Currently, I don't know if we're planning to put it in the product because other complementary products are really good at it, and we want to focus on doing what we're doing. Okay?
Okay.
Just continuing this demo, by the way, we just added a server while the system was running. Everything keeps on going. All of the file systems are still mounted. You didn't need to take any downtime. And we can show the same demo for a shrink, by the way. Let's do that.
And because other storages say it, but we actually do it, we support mixed workloads very well. So when your application runs, small IOs get high IOPS count and very low latency, but large IOs get you the high throughput, but also together, we actually see customers expanding their Weka system and adding more applications. So now they're starting enjoying the linear scale and aggregating their environment. So storage has been a very siloed marketplace. When you wanted another application, you got another box for it. And that happened because the previous generation of storage did not scale very well and did not support mixed workloads. This is another thing that we solved. So we actually see a lot of customers expanding, and it's a very important thing for them. It's once you start aggregating from other solutions, this is where a lot of the economics really kick in.
Okay, any questions up until now?
So for the customers that you have, are they mostly using solely Weka, or is it kind of like more heterogeneous with the storage?
Are you asking whether they're tiering or?
No.
What do they have in their data centers?
Yeah, exactly.
So some customers, I think you can differentiate it. Some customers are greenfield, they're new projects. In this case, what we've seen is that just putting Weka solves a lot of their problems, and Weka is what they have. A lot of these customers, even if they're greenfields and they have different projects, sometimes they have, most of them have other storage environments. I would say that we just had a huge press release in Genomics England where we completely displaced an Isilon. So did they throw this Isilon away or are still using it?
By the way, not only the Isilon, we displaced the Isilon, the extreme IOs. They had a single extreme IO for each compute. They had quite a lot of other solutions. So that's the case. And we have customers that use us for the application they brought us in, but also for Windows, also for the VMs. So we come in, we run their other stuff.
It's funny because we never just target the VM market, but I would say that 60-70% of our customers which bought us for performance are now putting their ES6 servers also on us. We will never sell only for that. But again, usually going to a customer, and we go to huge customers, supercomputing centers, petabytes of data, it's very difficult mentally for them to just displace everything on day one. So what we see is that we see smaller footprints, and when I say small, it could be in the single-digit petabytes for them, smaller footprints of Weka running alongside, and then once they'll get the confidence, they'll completely displace.
When you run on premises, like what's the smallest footprint you guys can go in?
So the smallest footprint would be a 4U environment. Usually that will be a two super micro big twins. It could be 2 HP Apollo 2K. A lot of our partners have this form factor of a 2U and 4 servers. That would usually be the...
And then you can start with just a single NVMe device that isn't large.
I would say that even our smallest footprint is there's an autonomous car company here in the Bay Area where we literally went to their garage where they bring the cars with the LiDARs, and they had 8 servers on the floor in the garage with GPUs, and they just installed Weka across these and run their training and inferencing on these literally in their garage. So that would be our smallest footprint.
So with all this, effort now to reduce power consumption to the data center, do you see customer asking for ARM CPUs with SSDs devices attached to that? So small ARM nodes.
We may have ARM-centered announcement at some point.
A really good question. Maybe in the next storage field day, we'll have answered it already.
Especially now in the cloud, these guys work a lot with hyperscalers.
Or even smart NICs, Enrico.
Huh?
Or even smart NICs. Or even
Smart
computational storage devices. All of those things could be options, I guess.
Imagine that. Would we that we worked with these, right?
Yeah. I think it's a logical thing to do. If your code is lightweight and can be run in containers, then you can see a scenario where you could offload
We are logical people. So.
Even if you don't offload all the tasks to that device, you could certainly offload components of it to make it work faster. And that would certainly address what Enrico's, I guess, raising as a...
I want to say one last thing, the NFS. And another thing that we saw, and I think that's also important, compared to some other environments, we see it a lot with NFS or SMB. And this is a question that we didn't know even that really bothered customers until it started surfacing from many customers. Many customers, or a lot of our customers, are worried about the stop IO time in case of a failure, a hardware failure. So I have an NFS appliance. One of the heads failed. Now I'm waiting for 1 minute or 30 seconds until my IOs resume. So that's every second there is cost them a lot of money. What we show customers, and actually we have a demo, but it's probably too small for us to see, is that dropping a node, we have a 10 to 11 kind of pause until IOs are continuing, but until they are dropping to the system. So there is no, if you're familiar with the SCSI timeout, there's no 30 seconds SCSI timeout. There's no 60 or more seconds where you have with other appliances. That's considered pretty immediate for these customers. So that's another huge, so again, we're talking about performance, and performance comes in many aspects: good pass, bad pass, throughput, latency, mixed, and also when things like that happen. Great. Final questions for next year, maybe?
By the way, did you end up showing encrypted performance, or?
I think I did.
So the metadata scales, all that stuff, is it primarily in memory and then backed up to storage, or?
It's all on NVMe. We just figure out some of that may be in memory, but if you look at our configuration, we don't configure with a meaningful amount of memory.
But usually that question is in terms of durability and distribution.
Well,
there's really no caching involved in the solution as far as I
know. No, because the problem is once you start relying on caching, you're going to run out of cache, and then the performance is not going to be great. And it's just better to not do that. And by the way, if you protect your data +2, metadata is protected +2. If you protect your data +4, metadata is protected +4.
For the customers that need a NFS anyway, so do you provide, Ganesha, something like that, and pre-installed or, best practices something, or is it up to them to?
Show you. So actually, as part of our UI, you get to configure NFS and/or SMB. So we're fully multi-protocol, so you can access the same data over NFS and SMB and our POSIX driver.
What do you use?
And that's the configuration. So currently, we're using our own implementation of NFS, but we are moving likely soon to a containerized environment of Ganesha, just so we can support more of what it does. SMB, we're using our own customized version of Samba. But again, from the customer perspective, the customer doesn't need to manage anything. Customer just need to configure it in our system and decide where it will run.
And we
So it's all included when they buy.
It's all included, yes.
And for Windows, we would get your UIDs mapping for Unix, and we hook up to it automatically. ACLs are translated between the NTFS ACLs on SMB and the POSIX ACLs on POSIX. So a lot of things that you work hard on configuring with previous generation filers, you basically get out of the box with Weka.
Which version of SMB?
Up to 3.2.
Just one last thing before being kicked out of the stage. So just a client running on MNT Weka 1, which is an unencrypted file system, doing 162K IOPS. By the way, which is huge because other file systems sometimes can give you 10 or 100. And this system, our minimal footprint, can give you something like 4 million IOPS. And when I'll run it on an encrypted file system, we'll see a similar number.
And show also similar latency.
Exactly. So definitely our encryption is built to not impact your I/O path as well. It's simple to configure. You don't need to configure Kerberos and all of that fun stuff. And you don't drop performance. So our cores are being used for that as well.